All right, here's our video, the most massive star. And up there on the top, you see R136A1, but the picture actually, a little blurry though, is the Pistol Star, which is a very massive star. Now, when I say massive, we must some people get confused with that. We're not saying the largest star, because the largest star is by far is UY Scuti. Let's write that down. And if UY Scuti was in our solar system, it would almost go to the orbit of Jupiter. Let's look at a picture of that. And get our pen ready, just in case. So here, look at this. Look at our solar system. We have, here's our sun over there. Put a little red dot and so forth. And we have Mercury, we have Venus, we have Earth. We have Mars, and then we're going. And here's Jupiter's orbit, right? So UY Scuti, right over here, is the largest star, but it's not the most massive star. So again, when we're talking mass, we're talking which has the most matter in it. And Polaris, the Pistol Star, which we talked about, is more massive than UY Scuti. But also, we'll talk about R136A1. And before we go to R136A1, they got to get a new name for that too, right? Let's just talk about the Pistol Star anyway, because it emits an enormous amount of energy. The Pistol Star, what should we use? Let's use white. Pistol Star. We say is a blue hypergiant. And it emits an enormous amount of energy, as I said, and it's losing mass, and it's old. It's old for a hypergiant, for a blue hypergiant. They have very fast lives in terms of stars, right? They can live for millions of years, whereas our sun can live for billions of years, right? So right now, the Pistol Star, it could be maybe 2 million years old, which is a baby if you think about it for stars. So it's at the end of its life. Whereas R136A1 is a red, should use red, right? It's a red giant, unlike the Pistol Star. All right. But the Pistol Star itself is, even though it's smaller than UY Scuti, it's much more massive. It's about 100 to 150 times more massive than our sun. And when we're talking about what could make a black hole, that's the that's the criteria. So there's a possibility when the Pistol Star blows, when it goes supernova, whenever it goes supernova, and it's at its end of its life, it may become a black hole. But the strange thing also, UY Scuti, even though it's the largest star, it's only, and we'll get our pen, change it to red. It could be anywhere between 7 to 20 times the mass of our sun. This star, the largest star so far that we have seen, will not become a black hole. It doesn't have enough mass. All right, and here's the Milky Way. And we got our pen going here. So as you can see, this is where our sun is. Don't be fooled by this scale. I mean, the Milky Way is enormous scale. So here's our sun over here in the Orion arm. So if we're looking at UY Scuti, it's probably around here somewhere in this area, about 9,000, a little more than 9,000 light years away. And Pistol Star, though, it's closer to the center, so it could be anywhere around here, right? It's close to the center. And in the center, by the way, we have a black hole. In fact, Milky Way has a lot of black holes, but we have a gigantic black hole over here called Sagittarius A. Let's write that down. Put a little arrow over here. It's a super, super massive black hole. So that star, before it was a black hole, must have been enormous too. Now think about the Pistol Star. It's very close to it. And so when that goes supernova and becomes a black hole, we'll have these enormous black holes next to each other whenever that happens. Now, the most massive star, however, as I said before, is not even in our Milky Way. It's in our it's a satellite galaxy. Well, it's not really a galaxy. It's really a nebula, the Tarantula Nebula. All right, and here's the galactic plane of our Milky Way. And in this large cloud here, the Tarantula Nebula is actually, well, let's get my pen working here so I can point it to you. All right, and we'll use red, why not? So right here is this point over here. This is the Tarantula Nebula. And this is where we find our R136A1, which we got to get a new name for. So this R136A1 it's smaller than the Pistol Star, but it's outside our galaxy. And it's about 160,000 light years away. 160,000 light years away. Remember, this is how far light can travel 6 trillion miles in a year, to tell you how far away this is. Right? There's nothing faster than light. 160,000 light years away. It is a blue star, and blue stars do not live long, but they are the hottest stars, and it could reach temperatures, let's put it over here, put a little arrow, of 46,000 Kelvin. That's hot. And it's about 1.5 million years old. So it's in half. It has another 1.5 million years to go, roughly. That is 3 million years is nothing for a star. Like our sun's going to live for billions of years. It already has lived for 5 billion years, close to it, and it will live for another 5 billion years. But blue stars do not live that long. So just to review here, R13681 is the most massive star that we have seen so far. And there could be others at it. But it's not in our galaxy, though. It's outside our galaxy. It's actually part of our satellite galaxy. But inside our galaxy, the most massive star is the Pistol Star so far. And here's a little comparison of R13681. Now, it's not, when I said the temperature of 46,000 Kelvin, that's like 82,000 degrees Fahrenheit. And that's just the surface temperature. I'm not talking about what's inside of it. Surface temperature of the sun is like 10,000 degrees Fahrenheit. The hottest star that so far we have a surface temperature of 210,000 Kelvin. That's WR102. All right, and just to review, so just because a star is large, like UY Scuti, doesn't mean it'll become a black hole, and it doesn't mean it's the most massive star. We know that the Pistol Star in our galaxy is more massive than UY Scuti. And the one we've seen so far outside our galaxy in the Tarantula Nebula is R136A1. And both of those I mentioned have the potential to be a black hole. There's a lot of stars in our galaxy. There could be billions of stars, but only a fraction could become a black hole. And we already have a lot of black holes in our galaxy, especially in the center, Sagittarius A. Okay, that's our video today.